Hi guys, Marco here from 3D Survey. Today another exciting webinar about benefits of using photogrammetry in road mapping. We still have 10 minutes, so feel free to wait a bit and let's start in 10 minutes. Recording button, so this webinar will be also recorded. After the webinar you will get a recording link, so you can watch again this webinar if you missed something or something like that. And let's officially now start with our today's webinar with the topic benefits of using photogrammetry in road mapping. I'm really excited about this one because there is a lot of tips and tricks, a lot of field experience which we will share today with you. Guys, feel free to set your question in chat box. I really motivate you to set your questions also during the webinar. And if we are not going to answer them during the webinar, we will definitely take time at the end and answer them question by question. More question we get, I think more exciting can be, because your questions are the really ones who brings the most problematic things out, and we can solve it immediately. Okay, so this webinar is a live webinar, it's happening now, so let's go and do efficient work. Everything will take us approximately 1 hour or maybe a bit longer, so I think it's not going to be too hard for you. And yes, take some notes, write something if you have questions, or mark something after the webinar. Of course, you can also contact us, set us questions, and so on. And if I start now with today's overview, so this webinar will be in this webinar we will show you how easy it's actually to map 10 kilometers of road with the help of drone and our 3D survey software. We'll providing you all the necessary steps from the capturing data using DJI Phantom RTK drone and to creating your first roadmap with 3D survey. So we will go step by step. We capture a short video presentation from the field, so you will get a really good feeling how it looks like, what's the best option, what's the best approach to map such a large distances, and so on. And if we first look about problem and solution part, so to measure a large area with a total station or traditional devices is sometimes too time consuming. So as we already know, we need to measure point by point. This takes times, and now the technology is affordable. The drone costs around 5,000 euros or something like that. In addition, you need to purchase the software and you're ready to go, and you can map really quickly, as you will see today. Then we will see some field experience for road mapping. So I capture a video from field when I was doing the mapping. This was actually a month ago or something like that. I try to explain most popular tips and tricks inside. If there will be any additional questions from you guys, feel free to set them. I will be more than happy to answer them. And we will discuss what's important for safe data acquisition, so for safe data capturing in the field, how to plan a mission, and how to set up your cameras depending on outside sun and so on. Then the third point will be the processing part in 3D survey, so the workflow, how to optimize your work in an office. And of course, at the end, questions and answers. We will try to answer your questions. If there will be something too hard, I will come back to you via email or phone call or anything like that. And if we look a bit more, again, what are the problems of traditional surveying? So we know we need to measure point by point to later connect them in an office. This is sometimes time consuming because of too much details on a field. Surveyors need to decide what to measure and what not. So sometimes you need to go around the building, measure something, some kind of manhole or maybe a power line cable or entry of a house from the back side of the house, and you need to go around. If you don't have a GPS or if you don't have a signal GPS, you need to move with the total station. It takes time, and then sometimes you forget to measure something. So these are all realistic problems which can come with the traditional surveying. And then at the end, you get a vector results, so like points, lines, and areas, which are, let's say, not good anymore for modern field representation. So construction guys, architects, designers are more and more used to get fully realistic data, like realistic 3D models, digital surface model, orthophotos with high details. And we can see from our point of view, this is more and more popular. At the beginning, so a few years ago, this was quite really difficult to introduce those kind of data to them, but now they are really happy when they get this one, because it's just much easier for them to work, to design the future plans based on this data. So this is kind of a solution. Drone mapping can provide project data back in the day that could take a land surveyor more time and more money using traditional methods. You are just much faster in this case, safer and more efficient. So this is kind of really nice opportunity for construction companies working on road mapping projects. Let's start. Before we start with our video from the field, let me give you 2 or 3 questions in addition. So I will start pool. And my first question is to break ice between what country are you come from? So please write your answer in your chat box. So you cannot write in a chat, you cannot select the answer here, you need to write it in a chat box so that I have a bit of feeling what kind of audience do I have. So are most of them from Slovenia or not, or anything like that? So you need to answer those results in the chat box. Okay, Croatia, Germany, India, Italy, Macedonia, Turkey, Slovenia. Okay, Papua Nova Guinea, Turkey. Okay, quite an international audience. Thank you for your answers. And let's go to my second question. I will close this poll and you set another questions. Are you already 3D survey customer? So this means that you don't have a trial, you already have a license. Okay, so you have a 3D survey license, or you have a monthly subscription or something like that, so that I can know how well trained you already are, how deep can we go when we do the presentation, when you show the examples, or we go a bit more basic, and so on. Okay, about 62% already voted here, and we have roughly 40% of you guys already have a license, 60% no. Okay, cool. Thank you for this answer, so I can know how to go further with this webinar. Okay, great. Let's close this pool, and our next thing is, I would like to share with you is a video from the field. So some tips and tricks, some instructions how to map 10 kilometers of road in a day. Hi everyone, Marco here from 3D Survey. My goal for today is to map 10 kilometers of road. My equipment for today is Phantom 4 RTK and pack of 10 batteries. But before I will start with mapping, I warmly suggest you to do first the site inspection. Because it's quite a long distance, the road can go really up and down, and because the drone is usually flying in the single plane on the same height, you don't want to hit something, okay? In addition, you can quickly see if there are some high power line cables or maybe some mobile phone antennas. So it's just the safest side if you go first, drive the car along the road and see what's happening on the field. So let's jump into the car and see how it goes. When I do the road mapping, I usually map 1 kilometer of road with a single battery. I try to start the flight in the middle. This means that the drone is never further than 500 meters from home point, and I can always have a visual control over the drone. And when I do the site inspection, and I already try to imagine location where I could start with a mission. Okay, the drone is on, the RC is turned on, and I will go to plan mission. Because we are mapping road, we will select linear flight mission, and on the back screen you can already see our map. So some kind of global orthophoto based on which I can plan my mission. And I just need to place my starting point. I will start here, and then I need to fly over this road. You can see here the home point icon already. We have everything ready for flight, and I'm just picking the points in the center of road. And up here we can see actually the band length. It's 760 meters. Usually I'm doing 1 kilometer per battery. So, and I'm staying in the middle. So I have really good overview about the drone lens flight. Okay, now it's altogether 841 meters. Let's leave it like so for start. Then this value, expansion distance to left and right, means how many information I need beside the road. So I will just set 50 meters. It's more than enough for me because I need road and I'm, let's say, 5 meters left and right. So let's do it like so. Then I click on generate flight road, and you can see I immediately get 3 lines based on which the drone will fly. 3 lines are also the minimum for later processing to get accurate results. So this is already okay. I will just set 80-meter flying height. Most of the projects, if those are bigger one, like today, 10 kilometers of road, we map at 80 meters high. This is the best time performance leg. Speed 6.3 meters per second. I will leave this one. Full coverage, time shooting, everything is fine here. What I will set it here is camera settings. If you are more advanced, you can go and set the shutter priority. And because I have a nice winter day, so really strong sun, I will put it like 1/400th of a second. We have also documented about the camera settings, so if you're interested in, let us know and we can send you via email. Okay. Okay, so let's try with 1/400th of a second. If the weather would be more dark, so not so much sun, I would set it 1/100th of a second, so like this, but never go shorter time because the images will be blurry. But for day, strong sun in the winter, 1/400 will be okay. And distortion corrections on. This helps later calculate more nicer orthophotography. I will save those settings and go to advanced settings and increase also side overlap, so horizontal overlap to 80 or even 85%, because they really don't need 50 meters left and right from the road, and this will be more than enough. I will leave the vertical overlap to 80%, and we are ready for save. Save again. Okay, so the project name, let's do like so, confirm. Let's just check if we are in RTK mode. Yes, RTK is on, the connection is successful, everything is fine. And that's why click on invoke and click on start. Some informations, slide, and the drone goes up. So this was everything about the planning, 1 kilometer road mission, and we are already in flight mode. During the flight, we can see all the important information. So the first one is battery level, definitely. Then we see a map where the drone is actually flying. We can see also how far it's from the home point. We can pause the flight or anything like that. But right now, everything looks really, really nice. If you click on image, you can see the real-time image from the drone. And why it's here important, we can see we select the camera settings correctly, 1/400th of a second. The F value is 6.3, so the minimum would be 2.2. Maybe for the next slide, I will go to 1/600th of a second or something like that. So I can go even with a shorter time. And yes, the drone is mapping nicely. It's flying now the second line back again. As I already mentioned, minimum 3 lines are for good accuracy at the end, because the geometry between the images fits them really nicely. And this flight will take approximately 7 minutes. For this flight, I didn't use any ground control points because the end accuracy of this model needs to be around 10 centimeters. And I can usually achieve this with integrated RTK GPS in this drone. If I would have a standard Phantom 4 Pro drone which doesn't have a RTK GPS on it, I will definitely use ground control points for orientation. So I will place them before on a hill, measure them with the total station or GPS instruments, and use them later in the office for orientation. Our suggestion for number of ground control points per 1 kilometer are 10 ground control points. This will give you a really decent orientation and really high accuracy of your model. If you're interested to see the webinar how to map a road with the Phantom 4 Pro, so without RTK GPS, but using the ground control points, please write below in a comment section or chat box. And if I get 50 notifications from you guys, I will go out and do a second video with the Phantom 4 Pro. Okay, we are just before the finishing the flight. Few more seconds. Battery level still sufficient, and when it triggers the last image, the application will let us know that the finish is completed and that the drone is finishing back to home point. So now it will go directly straight back to home point and automatically land. Okay, so last few meters, as you can see, flying stable. And landing on exactly the same point we start the mission. Okay, I successfully managed to finish my first kilometer. Now I just need to repeat the same process 9 more times, and we are ready for processing in the office. Okay, just a second to prepare my microphone and turn back the camera on. So this was my introduction video from the field. Hopefully you can hear it well. So there were quite a lot of useful informations. Maybe just one more time, repeat the most important one. So definitely before you do a mapping for such a long distance, do a site inspection because of power line cables, high buildings, because of the terrain. You never know before how it's going. So this is my first suggestions. Check where you are flying, and this will help you also later to more efficiently split your project in smaller missions. Then the second one advice, if we repeat it, is try to start from the middle point. In this case, you have the best control over the drone, so you can fly always in a line of sight and so on. And try to start from the highest point. So then you will always have a good overlap between images, and also later in the office, you're not going to have issues with too less overlap and that some images were not being matched together. So this can happen really quickly because when you calculate the overlap between the images, you are calculating on a ground level. And if you have some high trees like forest with a 30 or 40 meter high trees, then up on the trees, you don't have 80% of the overlap, you have just 60 or something like that. And this is already critical, okay? Some of the drones, also RTK, Phantom 4 RTK, can follow the terrains. We never tried because at the beginning they had some issues. Not sure if it's no better, but we are still flying those projects like in a same flying height, and then you need to keep this in mind, start from the highest point. Then the third important point, if I repeat it, is camera settings. To get good results, it's great to know how the system works, to know the basic about the cameras. Of course, you can always go with the auto mode, but in my case, there were a lot of snow outside, a lot of white color, and I need to have a detail also on roads. So it's good way in this case to set your cameras. Just quick three tips for cameras. If you are living in area where we have 4 seasons, maybe during the summer when you have a strong sun, nice weather, I would set it somewhere 1,600 of a second when I go to shutter priority. During the autumn and spring, I will set it, let's say, 1,000 of a second. And during the winter, when you have low light conditions, like a lot of clouds or something like that, where you don't have a lot of light, go to 100 of a second. But don't go to 160 or 150 of a second because images will be blurry. Okay, this is the longest time the exposure is open, so you just need to remember this. Okay, I'm not sure if you recognized, we had turned off obstacle avoidance sensors. This was because we have a lot of issues long time ago with the sun, with the low sun, and if the drone fly directly to the sun, the sensors figure out, okay, it's kind of obstacles, and the drone stops and notice there is something, but the drone was on 80 meter. So then after the few projects, we figure out that the sun is a problem, And that's why now if you have some issues like so, that the drone is flying and then just suddenly stop in the middle of a mission and there is no object, there is no host, no power lines and nothing, this is probably because of the sunshine. And in this case, we just advise you turn off the obstacle avoidance, be additionally careful that you don't hit something, and everything will work really nicely. Okay, cool. Don't forget to set your questions in chat box if you will have some. We will answer them at the end of the presentation, or my colleague will answer them parallel already. Okay, we finished with the field work. We are back in office, and when we copy the images from the drone, it looks like so. So as you saw in my video presentation, I split those kilometers in more segments. Actually, in my case, 13 flights, which you can see them like so. And the DJI Phantom RTK creates subfolders for each flight. And if I open this one, I have here, for example, 169 images, and then next slide was here with about 156 images, and so on. So we immediately have every folder for every flight. And then we can decide it how to process those data. Okay, we have two options. The first option is that you copy all images. So open single folder and copy images in a folder where you have all images. And in my case, then you have 1075 images. So this is in case the complete road is in a single part, so that you don't have some separated parts. This would work. So you can import all the images in a single project and so on. But my suggestions to you is to work it the other way. So we suggest you to process battery by battery, because at the end this could be more efficient for you. Calculating time could be lower, and you also don't need such a strong computer for processing it. Okay, I'm using a standard laptop with 60 GB of memory. I can easily process battery by battery. If I would go and process 1000 images as a complete project, I would definitely need 32 or 64 GB of memory. Okay, so my suggestion is, again, process battery by battery, and later on you can join the results. And let me show you now how it works. I will turn on now the 3D survey software. I will start with a new project, browse it to my folder with images, select all the images and click OK. Then the standard telemetry important wizard pops up. So I will select EXIF data for the DJI Phantom drones. So we will read the coordinates from the images. I will set my coordinate system. We are in Slovenia. That's why the Slovenian national grid. And in addition, I can select also my GeoIT model, because we have an RTK drone with a 1 centimeter precision of images. It's great to have also accurate GeoIT model. 3D survey support most of the local GeoIT model. What's the approach? Send your local GeoIT model to support at 3dsurvey.si. We will convert this GeoIT model to 3D survey file and send you back, and you can import it then in your software. If you have a GPS instrument, you probably have also a GeoIT model, so it needs to be inside. So for Slovenia, it's Copper 2060, the latest one, and I will click on import. And when I click on import, I can see my telemetry data here. What we figured out here, so we see the image name, latitude, longitude, altitude, already transformed coordinates, and the accuracy during the data acquisition. because this RTK drone, the accuracy is written here 10 meters for horizontal and 100 meters for vertical. But I know it's 2 centimeters for horizontal and 4 centimeters for vertical accuracy. That's why I will correct this one. So I can do this here with a manually set precision and just set the 0.02 for X, 0.02 for Y, and 4 centimeters for Z value. Confirm, and now those values were changed, and those are realistic data. So this was just because the drone doesn't have a latest firmware on. We need to update them, and that's it. Okay, I'm satisfied with this one. I will click on close, and here I can see how the drone were flying over the area. Once again, I would like to repeat this one. If you like to get really accurate results out of it, fly minimum 3 lines, okay? So what does it mean? The drone needs to fly down, up, and back down, and this is minimum we recommend you for the highest accuracy. This is just because of the good geometry between images. If you would fly a single line, you could probably also get a model out of it and results, but at the end, the model will be probably a bit bent or something like that, or on some locations you're not going to get good overlap between images and you could have some issues. If you do like so, everything should be more or less fine, and the result you will get out of this one will be at least 100 meter wide or something like that, because we are flying on a height of 80 meters. So the cameras, the camera objectives are really wide, and you get more than you actually need from the model. Okay, if we see this telemetry in a telemetry view, it looks like so. And now what's my next step is on the right lower side, the bundle adjustment step. We have 3 approaches. I motivate you to use the hybrid one, which will be in the future probably the only one, because it's currently the most stable, give you the best results out of it, and just because this is a combination of those two, so from global and incremental. Okay, under the show more you have additional settings. So how hard can we use your computers, use the maximum power. Default values are definitely the best one here, and then the auto orientation will select after the bundle adjustment that the model will also be orientated based on telemetry, because we have good accuracy. If I will click OK here, I would start with the processing. This will take us probably half an hour, but we don't want to wait so long, so I have prepared here already the result of bundle adjustment step here, and I will just open this project. Okay, a few more seconds. So, and after the bundle adjustment, so let's say after the half an hour or something like that, this is so-called sparse point cloud. We can already see the rough estimation of the terrain. So you can see the camera positions. If I extend here my view on the right side, you can also see the 3D error for every camera. So this model is already orientated, and the accuracy of the camera position is between 1 centimeter and 10 centimeters. So this depends definitely on the RTK accuracy during the flight, and results in a horizontal position for your end result should be between 2 and 5 centimeters in a horizontal way, and up to 10 to 20 centimeters in a vertical way. If you like to improve this, in addition, you can just lay down 1 GCP target, or maybe 4 to have good control over it, and then you go into the centimeters. Okay, so this is result after the bundle adjustment, and then this is also already orientated, and then the next step we need to do is reconstruction step. For that kind of projects where you have a really a lot of data, big point clouds, long distances, I advise you to use the reconstruction level, maybe medium, because it's already good enough. You will see all the necessary detail out of it. And if you will later join more flights together, you are not having 500 million of points or something like that. Because on medium, I think I will already get approximately 20 million of points. Again, we are not going to calculate this one because it would take, let's say, 1.5 or 2 hours. I will cancel this one and open already prepared project. Just a second. This is it. So where we have a point cloud already calculated. Let's check if there are some questions already. I think not. Okay, cool. So this is after the bundle adjustment, and after the reconstruction, we already have point cloud here. So as we can see from on the medium level, we get already 23 million of points, and this is more than enough for such a project. We can see most of the detail already from the point cloud. The conditions on the field were really difficult because of strong sun and a lot of snow on it, but we managed to get kind of perfect point cloud out of it. And now after this step, we have two options. We could go and calculate a digital surface model or regular grid mesh, or we can go and calculate new full 3D mesh. For this project, I decided for regular grid mesh because we are designing, the construction guys are going to design here where the optical cable should go, and they don't need the dimension of trees or how high the buildings are. So they need a regular grid with a nice orthophoto, and then they can use our CAD tools to mark where the optical cable should go. And that's why I decided for regular grid mesh. Before I go and calculate the regular grid mesh, I will do the classification. So I will go the traditional way. I click on the classification step. Here are my standard parameters, which are good enough for 95% of the projects. I will just conform them with click on next. Now what I need to do, I need to select one terrain point. So I will just select one in the middle of the road. Then I'm just helping the software to define the terrain out of it. And we can see the most of other points are automatically detected. With the next, I do additionally the classification improvements. Okay, couple of more seconds to process this one. Cool. Those are my terrain points, all colored points. Let's rotate the model a bit, and we can see the terrain points are colored. Houses, vegetation, poles, forest are not colored. And now instead of delete selected, I will use delete other tool, and immediately all points are just terrain points. Let's clear the red color, and this is my result. Classified point cloud. Now the next step is mesh calculation. Let's calculate the regular grid mesh. For this purpose, I will use 0.5 meter grid cell size. This is more detailed as needed. Usually we are doing this on 1 meter. Hole filling mode all. I will do all the interpolation of the holes. The regular grid will be a bit bigger, but later on I can do the modification on it. And smoothing cell size 1 cell. So I don't want to have smoother surface. This function is maybe for the contour lines calculation, if you like to have smoother contour lines and so on. But in this case, I need to have as much detail as possible. And click on calculate. Okay, cool. And this is my digital surface model. As you can see it like so. The all interpolation gives me also those parts which I actually don't need it, but I can easily fix this like so. I will go and select my area of interest. Okay, right mouse to finish the selection, and now just like before, delete other, and immediately I have my area of interest. Really nice detailed digital surface model with the regular grid. Okay, cool. And this is already the nice basis for orthophoto calculation for this part. So next step here is orthophoto, calculate new one. Maximum resolution from 80 meters. In my case is 2.2 centimeters. Today I will go just to 4 centimeters to speed up the processing, that we don't need to wait so long, and click on calculate. And now the orthophoto is calculated. So this will take probably now 2 or 3 minutes to calculate the orthophoto on my laptop computer. In the meantime, we have some time for questions and answers, if there are some. Let me just see if there are some questions. There was one question, do equalization calculation, let me copy, okay, send to all now. So do equalizations calculation is needed for field measurements if the territory is more kilometer long and GCP are used? Not sure I understand this question. So this was question from Ante Gulba. Vit, maybe can you help me with this one if you understand it? Otherwise, can you set your questions maybe the other way, or we'll contact you after the webinar and fix this out, okay? Any more questions? No, currently not. Okay, cool. Once again, feel free to set your questions, don't forget it, okay? And let's continue now with my result. Okay, so here you can already see the orthophoto, which was calculated from the my model, from my project. It's not with the maximum resolution, but already from this one, I can clearly see the border from asphalt and so on. And now what's the end result? So this one, so designers need to create, need to design where the optical cable should go. And the nicest way to do this is maybe just to drape an orthophoto on my regular grid mesh. So I click on drape orthophoto. Yes, you have option to select which one orthophoto you would like to drape on it. Couple of seconds, and now we have here realistic 3D models with the texture on it, and in this way this is kind of perfect data type to draw 3D lines on it for this kind of purposes. So I will go to point cloud and turn off the point cloud, and now go to cat tab. Here I have the full CAD function, so I can create new layers like optical cable. Let's make the layer active. I can set the color, the thickness of the line to 3 that we will see it. Then I will go to my draw line tool, and I would like to snap node just on my regular grid mesh. So this is a triangle option, and I would like to have point clouds with the name and height on it so that I can also see the height. And now I can decide, depends on my field, on which side I would like to design my optical cable. Usually this depends based on the field, and I would just like to show you the approach, how it goes, and one small trick. And maybe, okay, I was parked here with my car, and let's say we go and start with connecting the line here from this side. So I know usually they go half a meter from the asphalt, and draw the position of the optical cable. Okay, like so. Then maybe there is a change needed to go to the other side. Let's see what kind of terrain we have here. Okay, this is just kind of a test to see how everything works. So, and in this way, you have a really nice presentation of a field and do the approximation of the position of the optical cable in my case. Okay, in this way I create now a 3D line. Now we know that usually the power line, the optical cable, the telephone line or anything like that are grabbed in the earth at least, I don't know, 0.8 meter deep. If you would like to move these points, so lower the height of these points, there's a trick actually. What you can do is you can save those points as a point cloud points, and this goes that way. So we have cat data, and we will save cat as a 3D points optical, let's say like so. And we will set the TXT file format, because if I go to DXF, I will also get the 3D line and so on. With the TXT, I will just get the point from the line and save it. Default values are okay, and save them. And then if I go to my point cloud, let's turn the CAD line off. I can load in now those points. Okay, the universal point cloud important visor. Let's say the first column to 0, and this is X, Y, and Z value, and import it inside. I need to click on hide map and point render size to maximum to see those points, because I read them now as a point cloud inside. And what I can do now, I can select all my points, go to manipulate points, increase height, and lower those points for minus 0.8 meter. Okay, click on calculate. We move those points a bit lower, and now I can save those points as a minus 0.8, and again need to be careful, save them in a text file that I can read them back in a CAD tab, and save it. That's it. And now if I go back to my CAD tab to import those points inside, just data, load CAD, my manipulated points, again, set the X, Y, and Z value correctly, and import them again. And here we can see them with a white color, my 3D points with the lower red height. Okay, so if you need to design them like so, you can do it immediately. And now you can also connect new line based on this, and I will go with my new layer. Okay, of course you need to snap on points like so, and in this way you have 3D lines immediately on the right height position, which is actually going now under the model. Okay, okay, cool. So This was a short presentation, a bit tips and tricks, how to manipulate with those CAD data and so on. Here we have a pretty rough 3D model, which is good enough for that kind of purposes. So if you design the power line cables, or you need to get idea what's behind of the building, if there is asphalt or they have grass or anything like that, this is already good enough. We fly here from the 80 meters. We have nice detail out of it, but nevertheless, if you would need more detail or anything like that, you can go and fly lower. Maybe just for quick presentation, we were doing just some quick test where we fly actually manually on a 5-meter height or something like that. These were actually images from the field. I need to mention you can't fly with the help of an app. I need to fly here manually because the minimum flying height in an app is, I think, 25 meters or something like that. But I did just here for a test how much detail we can get out of it if we need it. And if I see the telemetry, how the images were triggered in this way, the cameras were pointing a bit in front. Then this was the sparse point cloud. And then, of course, the dense point cloud is in this case much more detailed. Okay, so this is fully different project. It was just more for fun to see what can we do out of it. But definitely we see the high potential also in this one, and maybe one of the next project will be road mapping for smaller areas for much higher detail information. And after the point cloud, we can calculate the textured full 3D mesh, and then this looks like so. Okay, so really detailed. And of course, again, if you go to CAD, you can draw then the CAD lines also based on these informations if you actually need it. So right now I'm connecting the curb on the lower side. Okay, let's create another layer with something red color. So this will be curb on the upper side, for example. Oh, I didn't activate my layer. Let's start on endpoint. So in this way. Okay, cool. This was just for idea what you can get out of it. Depends what you needed and so on. Okay, cool. I think we are ready for questions and answers if we have some of them. Okay, there are some questions. Let me go step by step. First question is, I would love to copy the questions, but looks like I can't do it. But I will read the question out. Okay, so I'm using a Phantom 3 Pro with GPS, with GCPs, also good enough to do this type of work. So the Phantom 3 Pro has different cameras, so it's not so powerful. It's rolling shutter camera. Of course, it also works, so you could get similar results, but definitely place more ground control points on your area. At least 10 GCP points per kilometer, but I would warmly advise you to invest a bit more, so and buy the Phantom 4 Pro, because there was a change in the camera. Phantom 4 Pro has already a 1-inch sensor, 20 megapixel camera, and what's more important, it has a global shutter. You can Google it on our website, what's the difference between global and rolling shutter. If you like to get accurate results and not use too much ground control points, definitely we would advise you to go with the Phantom 4 Pro. So not with the standard Phantom 4, Phantom 4 Pro. But nevertheless, Phantom 3 Pro also works. You can, if you take a bit more time, place more ground control points, fly maybe a bit lower, because I think it has a 12 megapixel camera. I will go on 60 meter or 50 meters, something like that. You can also go with this one, definitely. Okay. Next question. I'm mapping a dump site on mine with a white sand like terrain. What camera speed can I recommend? Okay, cool. Sometimes you have really hard terrains, so with no texture, as you describe it right now, really white sand. If you have strong sun, it's even more difficult. In this case, I will set the camera to 0.002 of a second or even more. So rather have a bit darker images and more detail on the image than have fully burn out image. Okay, you can maybe share some images with us later on, and we can also share the experience with you. But actually the algorithms who are detecting those interesting points are a really good one. One of our first project 10 years ago was coal mine, so fully dark stockpile of coal, and we were surprised how many details could we get out of it. But again, if you would have a better camera, the results would be even better. But with good camera settings, you can improve this definitely. Okay, hopefully, Vailan Chuba, I helped you with my questions. If not, feel free to ask another one or send us an email. Okay. Then let's go to my other question. Is Rudolf Borchin. Hi, how do I get the local elevation coordinate system into the program? Okay, just once again, support us with elevation coordinate system. Okay, so this is the GeoIT model. Support us with the GeoIT model, which you have it in your GPS system. If you don't know where it is, the easiest way is to ask the guy who sent you the GNSS instrument, how can you get this GeoIT out of the instrument and send us to us. We will transform it to 3D survey file format, send you back and give you the instructions how to install it. It's actually pretty simple. Okay, let's go to our next question. Mr. Adrian is asking, hello Marco, is this the project where you guys mounted the DJI RTK on a auto vehicle frame? Yes, we did test also this option, so we actually mount Phantoms also on a car and do some tests out of it, what kind of results we can get out of it. And it's kind of really interesting right now, but we help us in addition with some cameras, professional cameras, which also additionally record the road and combine everything together. Let's wait, maybe additional mode or something like that, and then we can inform you what come out actually from this kind of setup. So, but yeah, it's an interesting project. We try to optimize everything like equipment, the processing workflow, and so on, and share those experience with you. Okay. Then let's go a bit further down. Okay, and then Marin is asking, can you export the point cloud as a colored CIS file? Not sure, Marin, if you mean the point cloud to export, or maybe points which we created. So I'm not sure about this one, but point cloud, let me show you what kind of options we have for the point cloud. If you go to point cloud and save as, those are actually the file formats we are supporting them. So the standard PL epsilon, the laser file, ZLAS file, KO, TXT, XYZ, CSV, PTS, CLE57. Okay, and most of them offers you the color in addition, so should work. But not sure what the CAS file format. So I can check this later on and come back to you. Okay. Okay, we hit the 1 hour time. Let's just double check if there is maybe some additional question, which is okay. Hello Marco, here is the correction. I mean colored laser file. Yes, of course, not a problem. Just go to point cloud, save as laser file, and that's it. You can also, as you already probably know, you can import also point cloud data from different sources. Also, if you have a total station or laser scanner, you can easily import them in 3D survey. I suggest you, if you're using laser scanners from Leica or something like that, I suggest you the laser file format. The E57 usually cuts the coordinates off because of the too long coordinates, and then you don't have the data on right position. But if you save the coordinates as a laser file and import the point cloud like that, everything works perfectly. Okay, again, quick check. Questions? If there are still someone you would like to set it, please do it now. Would we have reply of this webinar? It's now another question. Yes, you will have the reply of this webinar. Don't worry. It will be even easier to watch for you because of this video. Everything will smooth a bit more smoother because of the webinar platform. Maybe there is a picture is breaking a bit, but hopefully you can get useful information out of it, and you learn something new today. Okay, cool. I would like to say thank you for today. It was a pleasure for me to host you. Hope I learned you something new. As already explained, if you have additional questions, send them via email, send them on support@3dsurvey.si. You can also call us if you like, not a problem. And please, if you still don't have it, go to our 3D survey webpage, download free trial, test out the software, try it out, anything like that. So feel free to know our software. If you need some help from our side, we are happy to help you. And hopefully you will join our next webinar. Thank you for today.